Now, think that you're in your garden on a sunny Sunday, and you're measuring the sound level. And friends are coming home, conversations are loud, people maybe drink a beer or two. It's very noisy. Then your friends are gone. You're on your own in the garden. You just put everything back in place. When suddenly there's an aircraft passing by, a very loud one taking off. And then, I don't know, the kids, the neighbors' kids are playing in the garden and make very loud noises. What I mean by that is that the sound level changes with time. It's not constant over a day, an hour, even a minute. It can change at any instant. So the sound level actually is something that depends on time. Of course, if you take a long measurement, you can associate a single spectrum to that long signal, for instance, over a day. But in practice, what you want to do, you want to see that evolution of the sound pressure level with time, and so you splice the signal in shorter period, 1 hour, 1 minute, 1 second, and then you associate a spectrum to each of them, and from that spectrum you derive a sound level which can vary over time. So the sound level is a time function. But what kind of average do we take for that level when we want to say that this has been a noisy Sunday, or this has been a noisy week or month or year? Well, the idea is to define not really an average, but an equivalent sound level. The idea is that the equivalent sound level is characterized by a constant sound over a reference period, which has the same total power or intensity content as the time varying signal. So in fact what you do is that you calculate the total intensity over the reference period and then calculate 10 times the log of that over I0. This equivalent sound level is usually, in fact in all cases, weighted with the A filter. Now, how do you define the sound level over very long periods? To compare one city with another, one street with another, 1 year with another. This has been standardized. In Europe, it's called the Lden, for level day, evening, night. You make measurements over very long periods, distinguishing 3 periods during the day. You have the day itself, the working hours, the evening that you spend at home or with friends, and the night where you sleep. And the idea is to measure separately the equivalent A-weighted sound pressure level during these periods, and to apply a penalty of 5 decibel to the evening level and of 10 decibel to the night level, because you are more sensitive to noise during the evening and night. And then making a clever average of that, reflecting the different duration of the 3 periods.